Okay, so we're going to start off with some Skill 2 problems. You should have seen all the gas laws it's assessing in Chemistry 1 last year. A few of these are a little bit of gas laws and Stoich, which again should have been from Chemistry 1. I'm going to do a couple of these straightforward problems so you can see how to work them. And then I'll make a new video for the challenge problems at the end. And the challenge problems will most likely be assessed on homeworks and not in an exam. But you are responsible for knowing how to work them all. So let's start off with the first one. We have an unknown atomic gas. It has a mass of 33.4 grams. Its pressure is 4.383 atm, temperature of 300 kelvins, and a volume of 46.9 liters. What is the unknown gas? So if you look at your answer choices, it lists a bunch of gases. So you should be thinking, okay, what would be nice to know that could tell me what the gas is? So looking at your periodic table, hopefully you think, well, if I just knew molar mass, I could figure out what the gas is. Well, how do you find molar mass? Well, isn't molar mass grams per mole? So look at all these numbers that we have up here. Do I have grams? Do I have moles? If so, I'll plug it in and figure it out. Well, I have grams, but I don't have moles. So if you were to list out all the variables that you do have, we have mass, yeah, you can see that. We have pressure, temperature, and volume. Hopefully you're thinking, well, with all of these variables, I can find moles, specifically with these three. What formula could I use with pressure, temperature, and volume to find N, moles? And I hope you're thinking of the ideal gas law. So I'm going to plug in everything I know for the ideal gas law. I'm going to solve for moles, and then can I just do mass over moles and then identify the gas? So first, make sure your units are good. We have atm, kelvins, and liters. That's perfect. With our R, that's what we need. So we're just going to go ahead and plug it in. So 4.383 times the volume of 46.9. We're looking for N. We know R. And our temperature is 300 kelvins. So go ahead and use your calculator and find N. I got 8.356 moles. So now that I know moles and I have mass, I'm going to find molar mass. So 33.4 grams over 8.356 moles equals. And so I got, I'm going to draw it down here so I have room, 3.99 grams per mole. So look at your answer choices. Which one of those has a molar mass of 3.99 grams per mole helium? Match it up on your periodic table. All right, so now let's go down to number 7. I just want to point out, number 1's a lot like skill 1. We're going to go to 7. Okay, on 7, we have a gas at this pressure, this temperature. We heat it to a new temperature. Volume's not changing. What is the new pressure? So pressure 1 is 6.018 atm. Temperature 1 is negative 25 degrees Celsius. Temperature 2, 263 degrees Celsius. If volume is constant, then we don't need to take it into consideration. It's staying the same throughout. And then pressure 2 is what we're looking for. Okay, make sure you convert these to kelvins before you try and plug it in and solve. This will be 248 kelvins, 536 kelvins. So there's 2 ways you could do this. The first one is you could know the gas law that deals with P and T. And so that would be P1, T2 equals P2 T1, right? Which is the same thing as P1 over T1 equals P2 over T2. Or maybe you just know the combined gas law. Right? If volume's staying the same, why don't you scratch these out? And then you're left with the same thing. So it's whichever way you want to know it. Usually just memorizing the combined gas law and scratching out what's constant. A little less to memorize. So now I'm just going to plug in what I know. And make sure you're flipping your temperatures when necessary. Don't mess it up because you're not paying attention to the ones and twos. Right? And then let's solve. ATM, which is B. So that's a straightforward chemistry one. What do I have, and what gas law should I use? Let's go to number 8. Ozone's unstable, reacts to form oxygen gas. So this is our balanced equation, gas to gas. What's the pressure inside a 5-liter container? So we have volume. We know our mass of ozone. It reacts completely at 37 degrees Celsius. So isn't that 310 kelvins? Assume the reaction occurs at constant temperature. So 310 kelvins is going to stay at 310 kelvins. All right. Do that. So I want to know pressure after the reaction works. So don't I know mass of the gas that I'm beginning with? I don't have a limiting reagent because I only have one reactant. So if all 7 grams react completely, we need to figure out how much gas does that produce, because at the very end, after the reaction is done, there will be no ozone left. So the only thing responsible for the pressure at the very end is the new gas that we made. So let's figure out how many moles of gas of oxygen we can create. And the reason I'm choosing moles instead of mass is because most of my gas law formulas have N or moles in them, not mass. So this should be a stoich problem. You can set up a chart. If you don't like the chart, then work 7 grams of ozone to moles of oxygen. So we have 203 to 302. Easy little chart. So we start off with 7. Molar mass is 48. Coefficients are 2 and 3. And I'm going to work it to moles. So 7 over 48. 0.14583 divided by 2. 0.0729. Move it over. Multiply up. And so our moles of oxygen that will be exerting the pressure is 0.21875. Now I know moles of the gas at the very end. I know temperature of the gas at the very end. I know volume of the gas at the very end. What formula should I use to find pressure? And since we have 1 of everything, you should be thinking ideal. So P times volume times moles times R. I'm just going to write R, but it's 0.0821 times 310 kelvins. And pressure will equal, let's figure this out. .11 ATM. Let's see. I just want to show you one thing about 13. 13 is the same question, pretty much. but it's asking for pressure in kPa. So you would solve it just like 8, but at the very end you would have to convert ATM to kPa. So if this makes sense, then maybe just do the conversion since the numbers are the same. But if not, rework it and then get it to kPa. Right, and let's do 17 before we do any challenge problems. All right, so we have this gas, C3H8. We know its pressure. We know its volume. We know its temperature. But really, let's go ahead and turn that into kelvins. Okay, and I want to know what is the mass of the gas in the container. So I know what the gas is. And so it's not asking me to find molar mass of the gas. It just wants to know how much of the gas is in the container in grams. So what if I use PV and T and solve for moles? And then can I do moles times molar mass of this to get grams? So that's my game plan. So I'm going to do ideal gas law. Now I'm going to solve for moles. I'm just going to write R again, but it's 0.0821. And I'm going to plug in my kelvins. And so once I get my answer, I'll write it over here. So moles equals 6.533 times 2.37 divided by R and divided by temp. I got 0.3987 moles. Now I'm going to multiply that by molar mass. 1 mole of C3H8 times molar mass of 44 grams of C3H8 equals I have 17.54 grams. I'm just going to go with the closest one. We might have used different decimals. Maybe he used a more precise molar mass. All right? Oh, there you go. So you can see it. All right, I'm going to stop this video and I'll do challenge problems on the next one.